Hello everyone, welcome to another episode from Chedexcel. Today we are going to talk about the second part of the forces of attraction. So the last video we discussed about the London forces. So today I am going to talk to you about permanent dipole attractive forces and intermolecular hydrogen bonding. So let's start with the permanent dipole attractive forces. Now the term itself gives you the idea, permanent dipole. So the permanent dipole attractive forces actually arises in polar molecules, which you can find two permanent positive and negative ions charges. For example, HCl. So this Cl is delta negative, this H is delta positive. Another HCl molecule we can take, this is delta positive, this is delta negative. So this positively charged hydrogen can attract to the negatively charged chlorine. So that attraction is what we call as the permanent dipole attractive force. Sometimes instead of the term permanent dipole attractive force, we use the dipole attractive force as well, dipole slash dash dipole. But commonly we use permanent dipole attractive forces. Now any polar molecule you can have the permanent dipole attractive force. So the last video I put a link on top. We discussed about how to identify the polar molecules and the non-polar molecules. So any polar molecules contains permanent dipole attractive forces. When we just take the strength of this force, the permanent dipole attractive force is stronger than the London forces. But when you consider the overall forces of attraction, sometimes the most significant attractive force would be the London forces. That will depend on their many, that will govern their properties as well. We will discuss it in the next video. Here, because if the HCl molecules are axis like this, H and Cl, if they move like this, then you will have a strong permanent dipole attractive force. But you know the molecules move randomly, and when the molecules move randomly, we can't predict whether the negatively charged will come align with the positively charged atom all the time. It might not happen. So if it doesn't happen, we can't say the permanent dipole attractive forces are present in a significant manner in all the time. It doesn't happen. So what happened here is, we can say the polar molecules contains permanent dipole attractive forces, but it might not the significant forces of attraction. For example, when you talk about HCl, HBr and HI, we will talk about this stuff in the next video, but I will just tell what it is. So all of them are polar molecules. HCl have the strongest permanent dipole attractive force. Why? The chlorine has the higher electronegativity than bromine and iodine. But when you talk about their boiling point, Hi is the highest, not HCl. The reason is, the more predominant forces of attraction here in HCl, HBr and Hi is London forces, not permanent dipole attractive force. So simply you can remember, any polar molecules contain permanent dipole attractive force. That's it. So any polar molecules contain permanent dipole attractive forces. When you just think about the strength, it is stronger than the London forces, but overall usually the more predominant or more significant forces of attraction present in polar molecules will also be the London forces. It is not fixed, but it might be. Now other than this permanent dipole attractive force, something is there called induced dipole attractive forces. So sometimes due to this polar molecule, it can induce a polarity of a neighboring atom. So we call it as induced dipole attractive forces. But usually we don't get those stuff in unit 2. The other thing is to remember is, if you can remember in O level, so you might have heard it in somewhere else as well, we use the word van der Waals forces. Remember, van der Waals forces is a force of attraction type that we actually tell it for the combined of London forces as well as the permanent dipole attractive forces. So a molecule which contains both London forces and permanent dipole attractive forces like HCl, we can simply say HCl contains van der Waals forces. So it indirectly say that it has permanent dipole attractive forces and London forces. But in unit 2 we rarely use the word van der Waals forces, van der Waals, right? We use the word permanent dipole attractive force. So that's what you have to remember. You can have permanent dipole attractive force in any polar molecule, right? So we know about London forces. Now we know about permanent dipole attractive forces, and we'll move to the third type, which is very commonly comes, that is intermolecular hydrogen bonding. So the third type is intermolecular hydrogen bonding. The first thing I want to tell you is, even though the term bonding is there, intermolecular hydrogen bonding is not a type of a bond, it is a forces of attraction. Usually we have 3 types of bond, or we can say 4. We have only metallic bonding, ionic bonding and covalent bonding. I told you 4 because in covalent bonding we have something called dative covalent bonding, but other than those 3 types we do not have any types of bond. Even though the word bonding is there, intermolecular hydrogen bonding is not a bond, it is a force of attraction. Now the term intermolecular hydrogen bonding says hydrogen bonding present intermolecular, but there is something called intramolecular hydrogen bonding as well. In intramolecular hydrogen bonding, we will talk about hydrogen bonding present inside the same molecule. Usually intramolecular hydrogen bonding mainly you can see in DNAs and sometimes in proteins, not sometimes, mainly in proteins, and DNAs you can see intramolecular hydrogen bonding, but usually we have intermolecular hydrogen bonding. Now the importance of the hydrogen bonding is, we usually use the word hydrogen bonding. So sometimes in this video, instead of intermolecular hydrogen bonding, I will use the word simply hydrogen bonding. So in hydrogen bonding, the main importance of the hydrogen bonding is, it is mainly formed in between some specific atoms. Usually hydrogen bonding is formed, we say, in between NOF atoms, the molecules which contains NH bond, OH bond and FH bond. What are the molecules which contains NH bond? Simple one is ammonia, NH3. We have N2H4, we call it as hydrazine, and commonly RNH2, we call them as amines. So we have intermolecular hydrogen bonding in those molecules. OH bonds, simplest one is water, H2O, hydrogen peroxide, H2O2, alcohols, ROH, carboxylic acid, RCOOH. These are organic molecules. So these molecules we have intermolecular hydrogen bonding. FH normally FH we have in hydrogen fluoride, HF. So there are many more, but simply we have intermolecular hydrogen bonding in these molecules. Now remember, it is must to have a OH NH FH bond. For example, let us say this is, you learn it in organic, this is called as aldehyde. The type is aldehyde, otherwise this is ethanol or ethanaldehyde. The aldehyde, you have oxygen and H, but it does not have OH bond. As it does not have an OH bond, we do not say aldehydes contains intermolecular hydrogen bonding. Aldehyde is polar, so it has permanent dipole attractive forces. As I told you earlier, any molecule contains London forces. So aldehydes contains London forces and permanent dipole attractive forces, or other way around we can say van der Waals forces, but aldehydes does not have intermolecular hydrogen bonding. But alcohols, ROH, right, ROH, it has OH bond. So ROH contains permanent dipole attractive forces because carbon and oxygen bond is polar, it has London forces because it has electrons, and it has intermolecular hydrogen bonding as well. So intermolecular hydrogen bonding mainly occurs in between these molecule atoms, NH, OH, FH, we call them as NOF atoms. It is not the case all the time, but generally we say those elements. For you guys, that is enough. There are cases that scientists have found intermolecular hydrogen bonding with other molecules as well, but we do not have to worry about them that much in unit 2, right. So, why do they form a different kind of permanent dipole attractive force? Because due to the high electronegativity difference. NH-OH, FH, that the electronegativity difference is so high. So, they tend to form a different type of attractive force, right. So, intermolecular hydrogen bonding is actually a different type of permanent dipole attractive force, a specific type. The other thing you have to know in hydrogen bonding is when these hydrogen bondings are formed, they have a specific way of doing so, right. So, if you could see earlier NH3, ammonia, hydrazine and amines like that. So, when intermolecular hydrogen bondings are formed, it has a specific way of forming, that is always the hydrogen bonded hydrogen atom always tend to have 180 degree angle or closer to that. For example, let us say H2O, this is the shape of water molecules. We will learn about the forces, shapes of molecules in unit 1. This hydrogen atom can attract to another lone pair of another water molecules. So, this is delta positive, this is delta negative, this bond angle is 180. So, I just drew only one intermolecular hydrogen bonding, but you can have hydrogen bonding over here, right. You can have hydrogen bonding with this one, this one and this one. So, simply one water molecule can form 4 hydrogen bonds, right. So, that is the hydrogen bonding in water. So, let us say this is hydrogen bonding in H2O. Let us say if you draw hydrogen bonding in ethanol, you can have CH3 CH2OH. CH2 CH3, delta positive, delta negative. If I draw the different color, the hydrogen bond, the bond angle is 180. So, there are very common questions they ask us. Draw the hydrogen bonding in ethanol, draw the hydrogen bonding in water, right. Those are very common stuff they ask, right. So, intermolecular hydrogen bonding is something like that. So, they are mainly formed in molecules which contains NH, OH and FH bonds, right. The molecules which contains NH, N and oxygen, but it does not have a NH, OH or FH bond, they do not have intermolecular hydrogen bonding. So, simply the intermolecular hydrogen bonding is formed in H2O, H2O2, ammonia, alcohols, carboxylic acids, ammonia, amines, hydrazine, right, hydroxylamine, NH2OH, those molecules contains intermolecular hydrogen bonding. Usually we say intermolecular hydrogen bonding is the strongest forces of attraction, followed by permanent dipole attractive forces and London forces. But as I told you earlier, sometimes the overall, when you talk about the overall forces of attraction, overall strength, London forces would be more predominant than both hydrogen bonding and London forces. Mainly in organic compounds like ethanol, methanol, small alcohols, the main or the predominant forces of attraction would be intermolecular hydrogen bonding, but huge molecules like hexanol, right, heptanol, hexan1 or whatever those, when the carbon number is increases, the predominant forces of attraction would be London forces, right. So, those are the simple things that you have to know about forces of attraction. So, today we discuss about the permanent dipole attractive forces and intermolecular hydrogen bonding. So, the next video I am going to talk you about the factors affecting the forces of attraction or factors depend on forces of attraction, and that would be the last part of this chapter, right. So, this is it. So, if you think this is helpful, give us a thumbs up and consider subscribing. Thanks for watching.